Hello, sixth graders. Welcome to sixth grade math distributive property lesson. Pause while you write the lesson title in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is I can use the distributive property and represent it with algebra by completing practice problems with 100% accuracy in multiple attempts. The standard we'll be addressing today is interpret a context to construct an equivalent expression using greatest common factor, least common multiple, and the distributive property. Let's start with our key idea, distributive property. To multiply a sum or difference by a number, multiply each number in the sum or difference by the number outside the parentheses, then evaluate. So if you look at the example, it shows you that we can multiply 3 times 7 plus 2 by separating it out and multiplying the 3 times the 7 plus the 3 times the 2. And the same is true with subtraction. And to show that with algebra, it looks like A times B plus C equals AB plus AC. And the same is true with subtraction. Example 1 has us using mental math. So I see a lot of you using the distributive property as you use mental math in class. And you just don't think that you're using a property, you just think you've figured out a way to break up numbers and multiply. And you have, it just has a name. So it's called the distributive property. So when you have a problem like 8 times 53, many of you in your heads say, well, I'm going to multiply 8 times 50 and 8 times 3, and then I'm going to add those together. And I know that 8 times 50 is 400, and 8 times 3 is 24. And then when I add those together, I get 424. So you already know how to do this. You just now have a name for what you're doing, which is called the distributive property. Example 2, we're going to take this a little bit farther, where we're not just using the distributive property to find answers to things we already know. We're using it to make other calculations easier. So if we have a problem like 1/2 times 2 3/4, we can take the 1/2 and put it outside a set of parentheses, and then the 2 plus 3/4, remember that we can rewrite the 2 3/4 as 2 plus 3/4, and then we can break it up, 1/2 times 2 plus 1/2 times 3/4. And half of 2 we know is 1, and half of 3/4, if we multiply that out, 1 times 3 is 3, and 2 times 4 is 8, so we get 3/8. And then 1 plus 3/8 is 3/8. Let's take a look at example 3, simplifying algebraic expressions. So when you see this word simplifying, it means you're using as few terms as possible. So we're going to use the distributive property to simplify our expressions. So our first expression is 4 times n plus 5. And so we take the 4 and we're going to multiply it by everything inside the parentheses. So 4 times n plus 4 times 5, because there's a plus sign in the middle. So 4 times n is 4n, and 4 times 5 is 20. So that is as simplified as that gets. You cannot then add the 20 and the 4. That's as much as you can do, because the 20 doesn't have an n with it. So we can only combine things that have what we call like terms. So we're going to do the same thing with letter B. 12 times 2y minus 3. So we're going to separate it. 12 times 2y minus 12 times 3. So here we have a minus sign in the middle. So 12 times 2y is 24y. 12 times 3 is 36. 36 doesn't have a y after it, so we can't combine those two. So we have to stop right there. So it's 24y minus 36. That is our simplified expression. Letter C is a little bit trickier because there are 3 things in the parentheses. So we do the same thing. 9 times 6 plus 9 times x plus 9 times 2. And then we multiply. 9 times 6 is 54. 9 times x is 9x. And 9 times 2 is 18. And then we want to add together the things that have the same variable, which we call like terms. So in this case, we have 2 things that have no variable after them, which means that they are constants. So we have 54 and 18. And so we can add those together. And the book here says, well, we used the commutative property addition to put them as next door neighbors, which is an awesome way so you can see that they are the same thing. They're both constants. And 54 plus 18 gives us 72. And then don't forget to put the 9x back on the front. It does not combine with the 72 because the 9 has an x after it and the 72 does not. Example 4 is our real life application. Jose is X years old. His brother Felipe is 2 years older than Jose. Their aunt Maria is 3 times as old as Felipe. Write and simplify an expression that represents Maria's age in years. So we don't know how old Jose is. We just know he's X years old. So the expression for his age is X. Felipe is 2 years older than Jose. So we're going to add X plus 2. Maria is 3 times as old as Felipe. So her expression is 3 times Felipe's age, which is X plus 2. So it's 3 times X plus 2. So we were told to write and simplify an expression that represents Maria's age in years. So we wrote it. So this is the right part. Remember, when you have 2 verbs in your directions, you need to do both of those things. So we wrote the expression. Now we need to simplify it. So we're going to take the 3x plus 2 and we're going to simplify that. So we're going to multiply the 3 times the x and the 3 times the 2. So 3 times x is 3x and 3 times 2 is 6. And we can't go any further because the 6 does not have an x and the 3x does. So they can't combine. So our simplified expression is 3x plus 6. I'd like to review a vocabulary term that should already be in your words worth knowing. If it's not, you need to get it there. In an algebraic expression, like terms are terms that have the same variables raised to the same exponents. Constant terms are also like terms. So in our example here, we have 5x and 2x are like terms, and 19 and 2 are like terms as well, because they have no variables, and the 5x and the 2x have the variable of x. I'm going to show you another quick example here. So let's say we have an expression with 6x plus 5x plus 3xy plus 2y squared. So I'm going to show you what is like terms and what's not. So these two are like terms. this has nobody else in the expression who's exactly like it. There's no other term that has an xy, so it has no like terms. And the same is true with the y squared. There is no other term that has a y squared and just a y squared. So those two have no like terms. So when you read this and it says the same variables, it means exactly the same variables. So they have to look exactly the same, not just kind of close. So let's go with our last example, which is actually 3 examples combined into one. And it is combining like terms. So it says we're going to use the distributive property to combine like terms. And we're simplifying each expression. So we're making it so there are as few terms as possible. So we have 3x plus 9 plus 2x minus 5. So we need to think about what our like terms are. And it says we're going to use the commutative property of addition. So that means we just rearrange things so that they're next to the neighbors that they like. So we have the 3x and the 2x, so we're going to put those together because they both have x's, and then the 9 and the 5 are constants, so we put those together. So they're with the neighbors that are the same as they are. And then we use the distributive property, so we put the x on the outside of a set of parentheses, and we put the 3 and the 2 inside because that x is multiplied by both of them. And then we have 9 minus 5. So 9 minus 5 is the easy part. 9 minus 5 equals 4. And then we have 3x plus 2x, which equals 5x. Or you can add 3 plus 2 is 5 times x. So either way, you end up with a simplified expression of 5x plus 4. Let's look at letter B. We need to remember that each of these y's, since there's no coefficient in front of it, its coefficient is 1. So we have 1y plus 1y plus 1y, so that's 1 plus 1 plus 1 times y, using the distributive property, and 1 plus 1 plus 1 equals 3 times y. So our simplified expression is 3y. Finally, letter C. We have 7z plus 2 times z minus 5y. So once we break it all apart, we have 7z plus 2z minus 2 times 5y. That's what I was reading right there. And so when we multiply, we have 7z plus 2z minus 10y. And so using the distributive property, it looks like 7 plus 2 times z minus 10y. So that 10y is not going to combine with the z's. So we have 9z, sorry I scribbled on that a little bit, minus 10y. So we add those coefficients and we end up with 9z minus 10y as our simplified expression. I'll write it out there for you since I wrote on it a little bit. Here's what you need to do next to finish this lesson. You need to be sure your notes are complete in your ISN, complete your Google Form questions, review your lesson if you need to, and complete your Big Ideas math assignment in your Math Spiral notebook. Be sure you submit that when it is 100% correct, not before, and track your progress on your playlist.